Hello guys, welcome to the back leg rigging tutorial for the Giraffe. Let's go ahead and do the driver joint chain first. Let me grab my joints and duplicate it twice. Now select those guys. We can go search and replace name. We're going to search for JT and replace with JTDRV FK. And oops, let's do the one of the joint chain first. And for the other guy, it's going to be the IK. Alright, two joint chains. One for FK driver, another one for IK. For the FK driver joint chain and the IK driver joint chain, I actually don't need those twisting joints because they're being driven already automatically. Now I'm going to grab the FK ones and make them bigger. And it's going to be the radius here. So this is going to be the FK driver joint chain. IK driver joint chain will be this guy here. Let me also make it bigger, even bigger. Alright. Now let's do the blending first. I need all three joint chains. Alright, but I don't need the twisting joint. Let me go ahead and go to the node editor and add those guys in. Okay. Yeah, put them flat. It's gonna be here. Okay. So three joint chains. Now I don't really need to do anything to the end joint here, so let me kick those guys out. That gives me 5 joints down the chain. FK driver, IK driver, and the binding joint. Let me then go ahead and make them bigger, and we can start doing the connections. You can do that by wires, so we can align them in this kind of manner. So 2 driver joint chains, 1 binding joint chain. Okay, now we can go ahead and do the connection. If it's easier, we can maybe just bring them a little bit closer. Okay, and you're more than encouraged to use expression if you think you know how to do that. It's actually a little bit different than the expression we did for the facial expression, but you can do that. It's going to be actually pretty it's going to be faster than this. Anyway, let me do the node-based way. Blend colors, and I'm going to rename this blend colors to blend colors left back pelvis translate. Okay, and duplicate this guy, and this is going to be the rotation. Alright, and I need this thing to be duplicated, and those 2 pairs again to be duplicated 4 times for my other pairs. Okay, now it's time to go ahead and do the renaming. So this is going to be the hip, and hip here. Okay, and for these, I can probably go to the search and replace name. I'm gonna search for pelvis and replace with, whoops, replace with this time knee. So that's gonna be easier. Oops. Actually doesn't do that here. Anyway, so let's just manually do that. So this is gonna be the, oops, knee, and this is gonna be the ankle. And moving on to this guy. This is gonna be the cloud. Okay. Whoops. Alright, so that's the renaming of these guys. Let me grab everything here and press the P button to pin these guys. Okay, and I just need to do the connection. So translate, result, go to translate, rotation, and goes to the rotation. And that's gonna create these guys here. Let me bring them over and also pin them. Right, so let me go ahead and do the same thing for the others. Translate, output, let's translate, rotate, and rotation here. Alright. Again, it produces these guys. I have to pin them again here. In the older versions, you can actually have those things not in here. I just don't see it, the options here anymore. For some ugly reason, you should be able to turn out those auxiliary nodes somewhere, but it's not there anymore. Anyway, so translate, right? Translate and go. Translate, rotation. That one doesn't go, and rotation. Okay. I just want to find out who developed this new node editor, and why can't you just make those things not pop into the other side? Is that too hard to do? I don't know. Maya is getting sloppy in some of the things they're creating. Output. This guy, where is it? Ah, here. Okay. And the last one here. So translate, and rotation, and output goes to the rotation. All right. So these are my blend colors. Let's take a look. You can actually test that, but just to rotate the guys and see if the blending is working properly, which I think they are. That guy doesn't do anything. So, all right. So that's the blending part. It's probably the most boring and tedious part. Just connect and connect and connect. Okay, and then I need, of course, the slider for the transition. So let me do that real quick. I need to go create a nervous circle here, and let me duplicate this circle and make it bigger. Actually, just not bigger, but move actually 0.5 unit on the X direction, and make it half as long. Okay, and for this guy, I'm just going to scale it down like that. I just want to create some fancier range. I'm going to do this and do that. So that's the range now, if that makes sense. And that's my actual controller. So I'm going to go grab both, modify, freeze transformation, and this is going to be my AC, left, back, leg, IK, FK, blend, and that's going to be the range of it. And this guy will be templated, so I'm going to go ahead and do that. Oh, I also delete the history of those guys and go for modify freeze transformation, right? And for this guy, I'm going to go display, object display, and template. All right. And group them together. I'm going to call this GRP. Alright. So that's my slider. I'm going to actually move it to where the leg is. So maybe here. Modify match transformation, match all transform to bring it to that joint, and I can drag it out and make it bigger. And maybe flip it this way. Alright. Don't really want that 3 thing. Or that negative 180 should be good. Okay. So this is actually the slider here. Oh, I forget to set the range of this guy. So let me do that. So the range of the limit information translates, right? I'm gonna set up the X to be 0 to 1, and others gonna be all 0. So here they're gonna be all 0. Alright, now I can only move on the X, no other directions. Alright, for the slider to work, I just need to use that to connect to the node editor here. So I'm gonna add it in. My controllers translate X will be controlling the blend. And notice that those connections can all be done using expression if you think that's you're more like a coder than dragger, right? This is sometimes not a very easy thing to do, like doing those connections. It could be easier for you to do the coding part if you think that's your strength. Just do a expression there. You take a look, you can count the amount of lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is going to be correct because we have 10 or 5 pairs of blend color. Double check and see if they're connected to the blend, which they are. Alright, so this part of the transition should be done. I can grab that guy and also pin it, and this guy can be kicked out. Alright, so that's gonna be the blending. So now if I go ahead and drag the rotation, it's now IK taking control. I can blend back to FK. Alright, so that's basically the setup of the two inputs, IK system and FK system. Now after this, all you have to do is rig the IK and FK system. Okay, so let me go ahead and do that. The easiest one to go for is of course the FK system. Right, for the FK system, I just need to give them controllers. Right, and I have my code here to do that. Let me grab all the joints one by one and do the code, and all my controllers are being created for me. Right, 5 FK driver joint, and my code also does that OR constraint for me on the joints, so that it does that too. Okay, so basically what you do is if you want to do it manually, for every joint you create a circle, group the circle, match the circle to the joint, and use the circle to do OR constraint on the joint by selecting the circle first and then the joint, do constraint. Alright, that's the setup manually, but I did everything using the code, so I'm not going to do that here. And of course eventually change the shape of the curve, which I haven't done that yet here. So let me go ahead and do that. Oh, one more thing, I don't like the naming here. I'm going to go for search and replace name and search for search for DRV and replace with just a underscore just to get rid of the DRV part. Okay. Alright, so that's my controllers. I'm gonna go change their shape by going to the component mode and just, tweak their shape. Drag this guy out and maybe grab these two and just drag them in. Maybe just that one in. Just trying to give it a proper shape. So that's gonna be the first FK, and the second FK. Make it bigger, rotate it this way. The rule of thumb for creating the shape of the controller is lesser confusion and easy to select. Okay, if you have those two things, you're probably gonna your animator is probably gonna be happy. Okay, so let me do that here real quick and scale it in, and just give it some maybe fancy looking shape, but that's not that important in this case. Okay, so this guy here. And my last IK controller. Oh, my last IK controller here. Alright. So those are my controllers. Let me go back to object mode. I'm happy with these shapes. The next thing I want to do is, of course, put them underneath their hierarchy. So bow goes to the ankle, ankle goes to the knee, knee goes to the hip, hip goes to the pelvis. So it's like a hierarchy like this. Now my FK should be already working. Let me switch to FK mode, and FK is doing whatever you know what it's supposed to be doing, which is just basically rotating the joint chain. Alright, so that's FK setup. Very straightforward. Just for every joint, every FK driver joint, except the last one, you create a controller, you use orange constraint, and you put them underneath a simple FK hierarchy. Alright, that's the FK part. I can go ahead and close that folder now, and let's move on to the IK part. The IK part is always the complicated part. Okay, so for the IK part, it's actually going to be different than the IK we did earlier on the Sophia character rig. The difference is that two differences. One is that the leg is having 4 joints instead of 3. Another thing is we want to have that because of that 4 joint along the chain. We actually need to have one more control to shift the middle ones. Okay, so that's the two very different things. Okay, we have the driver joints. Okay, I'm gonna go ahead and duplicate these driver joints and rename this driver joint to pelvis IK spring. Okay, now you may wonder what is a IK spring. In those IK solvers, we have all different solvers. But only the IK rotation plane and single chain are available in the default settings. You can actually invoke one more solver called IK spring. You can do that by typing in IK spring solver in the mail, and it's going to run that. And when that is done, if you go to the skeleton, create IK handle, you see that you have this one more spring solver listed in the list instead of these two that we have earlier. And that's actually going to be the solver we use on this IK spring joint chain. And notice that we have now 2 IK joint chains, the IK driver joint chain and this IK driver spring joint chain. So we have basically 4 joint chains all together. If I make this guy even bigger, oh, it is even bigger. So 1, 2, 3, 4 joint chains. One is the binding joint chain, FK driver joint, IK driver joint, and now one more called the IK spring. Now I'm gonna apply that IK spring IK here on this IK spring joint chain. Go from the beginning to the ankle here. Okay, now to answer the other question you may have in your head is, what's the difference between this IK spring joint chain and the IK spring handle compared to the rotation plane? Well, the difference is, we can actually see that. Let me go ahead and duplicate this guy so we can compare. Let me use the old school rotation plane, or not old school, but the way we used on the character rig. Let's compare those two IK handles. This one is the IK spring and the other one is the IK rotation plane. Let's check them up, and you can see now they're already a little different. And we keep dragging, you can see that the IK rotation plane actually overshoot and overlaps or crosses this joint here. See that? It's crossed. This guy will go above, and this segment crosses the first segment. And you can see that on the other side, the spring joint chain will prevent that. So for this kind of setup, the spring handle is of course the obvious winner here, because it's not going to give you that crossing back that the rotation plane gives you, and that's why we do that. Okay, let me go ahead and delete this joint chain I duplicated. That one was just for demonstration purposes. Now we have this IK spring, so I'm going to call this one IK handle left back leg. Spring. This is the spring joint chain. Now you're probably wondering, why don't you just apply this on the original IK driver joint? Why do you create a new driver joint chain? Right, this is going to be too much joint chain. Okay, the reason being will be actually this. We want to be able to shift the legs around, and that requires another two IKs going across from the beginning to the knee here, and from the knee to the ankle we need another one, and those two will be eventually driven by this IK spring on a different joint chain here. Let's actually see that in real action so you know what I mean. So let me go ahead and do more IK handles. I'm going to go use the spring stopper again from the beginning here of the original IK driver joint chain to the knee of the IK driver joint chain. So now we have a IK handle like this. Okay, and let me do one more IK handle, single chain IK handle from where I left off, which is the knee of the IK original driver joint chain to the ankle of the original IK driver joint chain. So we have two more IK handles, and let me name those guys: left back leg. This is gonna be the I should call it knee, because it's on the knee, right? And the other guy, I should call it ankle. Alright, so I have the knee and the ankle. Those two are, two separate IK handles, and this one is a IK spring from the beginning to the knee. The other one is from the knee to the ankle. It's a single chain. Alright, that sounds weird, but why do we need these two? Because now we can actually use these two to kind of like shifting things around, if that makes sense. So let's keep doing a little bit more so you can see what we're doing here. So we have three joint chain, right? Let me go ahead and create some controls here on the IK part, so I can actually duplicate my FK ankle controller, Control D, and I don't need anything underneath it. And for that controller, we can grab these vertices, holding down X and bring it down to the bottom, and also scale it in so it's kind of like flat. And here I can just drag that and drag these guys forward just to create the controller for the IK here. Okay, and of course rename FK to IK. And Shift P to unparent it. Alright, so this is going to be the IK controller, right? And let me go ahead and parent that IK spring to the IK controller here. so that the IK controller controls this IK spring now. Let me go to the IK mode, but because it's a different joint chain, right, so it's not doing anything yet. And then what we do is we go select both the knee and ankle IK we did on the original IK driver joints, group them together, and call this IK left, back, leg, GRP, right? And for that group, I'm gonna move the pivot to where the ankle joint is. They're all at the same location. So, and I'm gonna grab the spring, IK spring joint chain, this newly created IK driver joint chain. This guy will be having a constraint on the group I just created for those other two IKs, a parent constraint. If you do that, you can see now the leg is following the IK, which is, you know, working on some level now. All right, but then it's time to reveal why I kind of need a different joint chain to drive everything first, and then another two smaller IKs. These two smaller IKs, let me group them one more time. I'm gonna call this guy IK left, back, leg, GRP, and offset, and also move the pivot there. And this offset will be serving that shifting thing I was talking about earlier. You just need to rotate this group. You can see now the leg is shifting. Okay, and that's actually pretty useful when you have them like doing this, right? When you have the leg going this way, and you can actually use that shifting to tell the leg to do something differently here. It's popping here when we do the pull vector constraint. That should be able to prevent that. But for now, this is what this is, what this function is, and that's why we need another joint chain to drive these two IK first, and also we have these offsets to drive them all together. Okay, all right. So let me go ahead and zero out my controller. And for this offset, I can create a controller or just a attribute. Let me do the easy way. Just give my controller a attribute. Let me call this leg shifting. All right, I don't need any maximum or minimum values, just add. And then I'm going to use this guy to control the rotation. Oops, let me clear the graph. And I'm just going to use my IK controller here on the wrist, on the ankle, to control the rotation here. And in this case, let's take a look. Rotation X. So left shifting will be controlling the rotation X. Now what that gives me is now I can use this to drag the leg up and down using the overall control. And then I can also use that shifting to shift the leg back and forth. Okay, all right, so that's this part. Final touch, the IK controller will eventually have a orient constraint on the IK driver joint on the ankle, so that I can use that to rotate it now. Okay, so that's the setup of the leg part of the IK, and I can blend IKFK with ease. All right. Now one little thing I didn't do here will be the pull vector constraint. And for that guy, I actually need something a little bit different too. Because if you look at the joint chain here, we are not a joint chain that only have 3 joints. We have 4 joints down the way. And our old way of doing or finding out where the pull vector is using this create pull polygon tool and holding down V to snap to the 3 joints, right? But now we have 4 joints, right? So this way suddenly becomes useless now, but because you don't know if you need to go for here or there and there, or you go oops, let me delete that. Or you go from there to the second one and to the end, right? how do you create that triangle? Because you have four joints now. You have 4 positions to snap to. So the solution will be a more deeper and more actually accurate way of finding out where the IK is, or actually a more logical way. So I'm going to go ahead and duplicate the IK spring here. Okay, and you have to unparent it. Make sure you do that, otherwise this is not going to work. Okay, make sure again, unparent it, and drag this guy out. Now you're wondering, okay, stop. Why are you creating more joint chains? I'm a little confused already. This joint chain is temporarily here for us to find out where can I find the IK IK vector's position. So I'm going to apply a IK on it, the same IK I did, which is the spring solver here on this joint chain. And then I'm going to go ahead and create a locator here and move that locator to the beginning of the joint chain, which will be here. Okay, now go ahead and freeze the transformation of this guy. Okay, and final step, not final step, but next step, you go to node editor, you pull those guys in, you connect the IK handle, the new IK handle I created, connect its pull vector to the translate of the locator. Okay, let me do that again. Pull vector to the translate. Now you're probably wondering, what is this, right? Why you're doing this? If you look at the locator's position now, it actually is pretty obvious of where it is. It's actually now right on the intersection, or the crossing points of that arrow from the IK handle, the white arrow, and the circle. And that's actually the pull vector is pointing exactly. Okay. And the conclusion then becomes that the pull vector value here on the IK handle is actually the value, or the location here. And it's also where, or a vector that the arrow of the pull vector is pointing to. Alright, let me go ahead and delete the testing joints. Those are just for me to get the information. Afterwards, I have a proper location of the locator now, and then we can go ahead and do our create polygon too, but this time we go from the beginning to the locator there. Sorry, let me do that again. Go from the beginning of the joint to the locator, and then to the ankle. Alright, now that's the triangle that we need, and I don't need that locator anymore. Just grab the vertices there and use the normal axis, go V and U, and that's actually the positioning of the knee. Okay, let me go ahead and create my controller real quick. I'm gonna go create a CV curve. Go get closer to the origin. Go from here right to. Oops! I also need one linear in this case. Skip that. Just doing those arrow things real quick. Whoops. Oops, that's wrong. Alright, so that's my arrow here. I'm gonna name this guy AC, left, back, leg, IK, okay, and group it, and name the group the same name with GRP. Alright. Oops. Why does it change to blend? I want to call it knee. I don't know why it's blend now. It's weird. Wait, where is my blend? Oh, the blend is here. I don't know why it's doing that. Anyway, so this is gonna be the knee GRP. Alright, and this guy will go, of course, to the position there. So I'm gonna snap it there, and I can rotate it to whatever way I want it to be. It actually doesn't matter. So maybe let me just make it rotate 90 degrees. Alright, and I'm happy with that. Just delete the triangle, and I can also just make it arced a little bit. Maybe that's too much. Okay, so that's gonna be the full vector control, and let me grab that guy and my IK spring, this guy here, do constraint full vector. Now afterwards, you can go check your joint chain, make sure that the joint chain are clean on the rotation. Okay. Oh, not there. Yeah. Okay, it's all clean, and you can now able to control the you know, where the leg faces. All right. Now another thing here though is that the original IK here, this guy, they also have a pull vector here, and if you allow them properly, this guy should be also able to do that constraint. So let me do that. Grab the controller and then the leg knee, do constraint pull vector. You see, should also able to pull vector that guy so that they're sticking exactly. All right. So now we have the full control. We have this guy to control the whole leg. We have the other guy to control the, you know, the aiming, and we have one more attribute here to control the shifting of the leg going back and forth. Okay, so that's the IK setup, and you can see that this setup is more complicated, and that's actually the common way that people approach the riggers are. This is the common approach that riggers do for the quadruped animal leg rig. Just because you have one more segment, we need that extra shifting, and that makes things a little bit more complicated. Okay. Alright, so this is going to be the leg setup, and that's going to be also the tutorial here. And for some cleanup, right? Yeah, I forgot to do that. For the cleanup, just go ahead and grab all the controls you did and group them together. Let's call it left back leg rig, and instead of that we can group different things together, like we can group the ACs, right? AC leg GRP, and that's gonna be the whoops, that guy also needs to be there. So 1, 2, 3, and that's the blend, that's the, oh, that's, yeah, okay, and that's the ankle, and what's that? Okay, that's actually all the controllers. Okay, and the IK there will be the IK handle group. You can keep that there. And for the driver joint chains, we have all the 3 driver joint chains created. Now you don't really want them to be, you know, you don't really want them to be underneath the original binding joint chain, so you can group them together. Let's call this JT left, JT left back DRV. Leg DRV, GRP. And this guy can also fall into the leg rig group. Okay, and the leg rig group eventually goes to the giraffe rig group, along with the neck and spine rig group. And that's gonna be it for this part. I forget to do the sorry, I think I forgot to do the visibility part. Let me just do that real quick, but you know how to do that, right? It's gonna be super simple. So I just need that guy in, and when that guy is 0, we're in IK mode. When that guy is 1, we're in FK mode. So it's going to be connected to the FK right away. For the IK, I can probably go ahead and grab the IKs. Better make the naming consistent. Okay, for these two, they're gonna be used for the reverse. So I'm gonna go ahead and do the reverse. Sorry this is taking so long, but there, things are just getting more and more complicated down the way when we were doing the rigging. So that's going to be the visibility of the other two groups, right? And now I have IK FK blending. And final cleanup, the joint is not really needed to be seen. The IKs, right? The IK handles can also be hidden, because we don't want to see these guys either. Alright, now we have a much cleaner hierarchy and viewport, and that's gonna be it. That's gonna be it this time. Okay, sorry for this if this is taking so long. It's like 41 minutes, but I think everything here, I want to explain a lot of stuff down the way, so it's gonna be taking some time, but still, like this should take you like 20 minutes more or less to do that, Okay, so alright, that's gonna be it for today. Next class maybe we can do more foot rig, and maybe we can do the front leg, and that's gonna be actually all the body. The torso and the neck rig are exactly like the character rig, so I didn't have that part recorded, but it's very simple, so you don't need to, I don't think you need to see that. Okay, thanks for watching, see you next time.